The air duct calculator is going to cover some stuff that the app is not necessarily going to cover, because you have square duct, rectangular duct, all of that kind of stuff out there that you don't have on the app itself. So we're gonna walk through that. So don't be scared. It's not really hard. I've got Jody working right behind you. I've got Mike's going to work right behind you. So if you get in a bind, just go ahead and grab them up, and let's have them get right on top of it. And I need to make sure that, Brady, that you are on top of this, because this is where you're going to continue on that training with these guys, okay? Fair enough. All right, so here we go. All right, here's your duct calculator. Everything is really kind of crazy all over. It's a lot of information, but this is my preferred duct calculator. When I first did this with Linux, I started using this style of a duct calculator. This is the same one that ACA uses, or the same style that they use, because it has multiple styles of duct work. So if you look right up here at the top, on the white right here, and white here, and the white there, that's all CFM. That's CFM. That's the volume of air. Is that right? All right. Let's look at something else. Up here at the top, in the gray area up here, that's going to be the friction rate. Down here at the bottom, again, that's the friction rate. That's going to be how much friction that air has to move through in that ductwork, and we're going to size a different way for each one of them. This is flex duct. It says wire helix flexible duct. So if I got flex duct that I'm trying to calculate, I'm going to use this scale right here. Does everybody see that? When it says wire helix flexible duct, if I'm dealing with a flex duct, I'm using that scale. Everybody follow? Good. Here's where I'm going to need the audience participation, because I'm going to ask a question, I'm going to turn around. If I got heads nodding this way, I'm going to say, okay, I'm going to move on. If I don't have it, then I'm questioning whether you guys are with me. Fair? All right. Next one. Equivalent rectangular duct. If I have a rectangular duct, any type of a plenum or a trunk line or anything like that, I'm going to put it on here. If you see this right here, you see this 5 going over and meeting up with this 12 right here. That would be a 12 by 5 metal duct with no lining on the inside. Okay, anytime you're dealing with this, whether it be the round duct or the rectangular duct, it's always the free area inside that duct. I'm never going to say, oh, I got an 8-inch round and measure to the outside, right? I'm going to measure to where the air is actually moving. Same thing I'm going to do here. So if it's duct board, I'm not going to measure the outside, am I? I got to get to the inside to get to
Okay, so if I have a 12 by 12 duct with 1-inch liner, what's the actual size that we're looking at?
He's giving you the dimensions. You got a 12 by 12 duct.
With 1-inch liner.
1-inch liner.
What is my free airspace inside of this duct? Oh no.
1 inch off of this side, 1 inch off of this, it'd be 10 by 10, yes? Good?
So we don't look at our CFM based on 12 by 12. We look at it based on 10 by 10. So y'all would take this little thing.
All right, so in this particular case, you're seeing that this 5 by 12 lines up, yes? You see how that 5 by 12 lines up? Mm-hmm. It's equal to an 8-inch round.
Oh, okay.
Does that make sense? All right. So we're going to move on. Next one we're going to look at is the round duct size. You see that that's right there in the middle. Is everybody good with that? Round duct size? Good, good, good. All right. Metal duct with no liner. If it's wrapped on the outside, that would be galvanized metal duct. And that's metal duct with no liner. Everybody follow that? All right. Let's look at the next one. Duct board is down here at the bottom. If I'm looking at duct board, I'm going to look down here. Everybody good? Good. The next one is duct with liner down here at the bottom. If I have a duct with liner on the inside, this is where I'm going to look. Fair? A lot of duct calculators, they'll either give you flex, they'll give you metal, they'll give you something, maybe even duct board, but they're all separate. This calculator, we built it so that you have everything built into one duct calculator, so you don't have to start looking everywhere. Fair? All right, so let's figure out how to use this. All right, so to Brady's point, he was asking you, what is the static pressure that you would be building to? What is the friction rate that you would be sizing your ductwork? Most residential design use the equal friction method, which means this method assumes that if you size the longest, ugliest duct in the house to a friction rate that you can get air through, every other duct I should be able to get air through it. Does that make sense? So I'm going to size to the ugly duct in the house, whatever that ugliest duct is. The equal friction loss method is based on 100 equivalent feet of ductwork, elbows, length of the duct, fittings, even the types of grills will be calculated into this formula. So, I'm going to ask you to do me a favor, and on the upper right hand side of your duct calculator, I want you to do this. I want you to put RA .08. Okay, right below it, I want you to put SA 0.05. Now that's return air is 0.08, and supply air is, oh, I'm sorry, the other way around.
Yeah, I was fixing to say, Rick,
I'm sorry.
I think it's supply 0.08.
Yes.
Return.
Supply air 0.08, return air 0.05. If you will do that for me, I'm going to tell you where those numbers come from, because it's not always that. And you'll throw these numbers out, and there's going to be somebody that's always going to say, So I'm going to show you where the numbers come from, because you know what, Brady? You're going to get that job, and you're going to have that ugly duct that's really ugly. And I'm going to have to change that at that point in time. And I need you to understand how to make that change. Fair?
Fair.
Good. Go to the friction rate worksheet. Where do I get that? JFGI. GFGI. Just frickin' Google it. Okay? If you just friction rate worksheet, there's an ACA version that you have to pay for the Manual D, or this is something that somebody has actually built on the internet. It's very similar to, and it works. So Google friction rate worksheet, you can get these worksheets available to you. So what are we going to do with this? We're going to find out what this friction rate is. I'm telling you, I think these numbers will get you 95% of the time, will get you accurate for what you guys are dealing with here in this market. So I like to give you this as a good starter point. I'm going to make sure that he understands how to do this so that he can change it if he needs to change it. Fair? Cool. All right. So, first of all, I got to find out, what did the manufacturer say that he's going to build that blower to be able to blow through? Yes? Good. So the first thing says external static pressure, inches of water column equals CFM. I'm going to go to the blower data sheet for that particular unit that we're putting in that house. And it says 100,000 BTU on high. It says if I'm going to get 2,000 CFM out of there, I have to do that at what? 0.5. Okay, so 0.5 gives me 2,000 CFM. I'm going to put 2,000 CFM and my 0.5 up there. All right, then I'm going to find out all the resistances that I have in the supply and the return, because I know that this blower at 0.5 will give me the CFM I need. Yes? Good. So I'm going to find the coil. On the coil, I'm going to go to the coil data sheet, and it's going to say this 5-ton unit will give me 1939 CFM if it's in the upflow position with a 0.15 across that coil. Everybody okay with that? So I look at Rude static. So here's the 3 tons. 3 ton, 3 ton, 3 ton. This is a 17-inch coil. This is a 21-inch coil. This is a 24-inch coil. All 3 of them could go onto that 3-ton system. Is that right? The manufacturer doesn't know which one you're going to put on there. This one has only a 0.13 static. This one has a 0.23 static. And this one has a 0.36 static. Which one's going to give me less airflow? the higher the static, right? Good, so if I'm putting this coil on there, I already know that I've got some restrictions to that duct system. It's the coil. Good? So just knowing what the coil static is going to be huge important as we start rolling forward. Making sense over there, huh, David? You got your head all going over there. I'm with you. I'm with you.
If they just stop, I'm gonna run into them.
That's good. That's good.
They decide.
So you guys are with me on this so far? Good? All right.
I can't see.
Let's look at this. I didn't know I was ever connected to it. All right. So let's look at this. A typical throwaway filter. 0.09 resistance. Look, all the different sizes. Look at the resistance. 0.09, 0.09, 0.09, 0.09. Everything is 0.09, right? So 0.09, 0.07, that would be a good resistance on a really basic filter. All right. Look at this one. It's 0.11. Every filter, every grill, everything's going to be different. So this one's 0.11. There's one of those practical pleats. 0.16 is their initial resistance. That's not bad of a resistance for a pleated filter. So we've got a pretty good resistance on there. What this is telling me here is that that's 1180 CFM that they're sizing towards. With 4 square feet on a 2424, it's rated at 300 feet per minute. So practical pleat is the only extended pleated filter that uses 300 feet per minute, whereas everybody else is sizing theirs at 500 feet per minute on the extended pleats. All right, here's another typical 1-inch pleat. Now look at this. Remember we just talked about that 0.09, and I said that's a good resistance. It's a very low resistance. Look at these pleated filters right off the bat. The initial resistance on all of these is 0.21. That's more than double where we were with the other filters, right? So if I have, let's just say that you're at a 0.7. If you're at that 0.7 and you just change out the filter from a pleated filter to a poly filter, we've already dropped 0.1 off of that. Doesn't that make sense? So now I'm back into that 0.6 where it's working. What's going on, boys? What y'all doing to my stuff?
Yeah.
All right, so depending on the filter we're putting in there, we're going to have to put that all in. So here's a MERV 16. Look at this filter. What kind of resistance do I have on that? 0.31. How restrictive is that filter? Pretty restrictive, is that right? Remember, how much did we have total that we could work with? Remember we said 0.5. If I had 0.5 total that I could work with, and the filter is already pulling out 0.31, how much does that give me for the rest of the duct system? Not much. Does that make sense? So what's going to happen to have the rest of the ductwork is going to have to be like this big in order to be able to get the air through, no resistance at all. Does that make sense? Good. So the type of filter we're throwing in there is going to make a big difference. So look at, here's our typical wall grill. What did I say the typical wall grill would be? Somewhere between that 0.2 to that 0.3? Good. So let's go with a good 0.3 there. So you see in where I got all these numbers, yes? So I'm filling back in here. The coil was that 0.15. Or if we were going to that 17-inch coil, it was 0.3 something. Is that right? Yeah. Good. Low efficiency filter, I went with the 0.11. That was that one that folded up. Supply outlet, that's that supply grill. That was that 0.03. The damper itself, 0.03. The return air grill, 0.03 on that one as well. It might have been 0.02. But I add these all up because these are the resistances that we just put in for that particular ugly duct run. That's 0.35. If I had 0.5 total to work with, I have 0.5 total to work with, and this is what I have for the resistances on that system. We need to find out how big the ductwork is. So how much do I have available if I've already used up 0.35?
0.14.
Good, so 0.5 is my available static pressure equals my external static pressure that I'm dealing with these device losses, and this is what I have available to use, yes, to size the rest of the ductwork. All right. So now I want to find out the total effective length of the ugliest duct in there. Because that's going to have resistance, yes? Long run is going to have resistance. That all of that ugly stuff like that is going to be resistance. Let's find out what happens. All of these fittings will have some resistance that we have to deal with, and we're going to go ahead. Would you think this would be harder to blow through than this one? Yeah. Okay. So we're gonna every one of these has a number assigned to it for that ugly duct, and here's those numbers. You're gonna find this in Manual D, that you'll be able to assign this to find the total effective length of something. So let's say right up here you have a 90-degree elbow in there, and that's that first elbow right there on that ductwork. If I have a 90-degree elbow, it's equal to 30 feet of straight run. If I put an elbow, it's equal to 30 feet of straight run. How many elbows do I want to have? You're with me now, aren't you? You're getting it. All right, so you're getting it. That's awesome. So if I have that 90-degree elbow, it's equal to 30 feet of straight run. If I have just a collar in there, it is equal to 35 feet straight run. If I just ran a straight duct straight out like that for 35 feet, I'd have the same resistance that I'm going to have with that collar. Okay?
The collar with a damper.
Yeah, collar, damper, yeah, collar, yeah. We're going to get in pissing distance at that point, so let's just go with that, and yeah, collar, and damper, okay? All right, let's look at another one. If I have a 45, a 45 is going to give me 10 to 20 feet. So what do I want to put? 45 or do I want to put a 90? Yeah, now you're getting it. See, because that's less length of duct, total equivalent feet of duct work, yes? All right, so you're seeing now where this is going to be able to, if I can clean up that ugly duct, I can help get a better static on this system. All right, so here's the ugly duct in our house. All the rest of them are just short branch runs here, here, and here. But this one is the one that goes through and goes all the way to the kitchen and back over there. It's the collar, and we said the collar was equal to 35 feet. We have 20 feet of duct. Then it goes into a 90. The 90 is worth 30 feet. 20 feet of duct is worth 20 feet of duct. I got another 90, another 30 feet. I got another 15 feet of duct, 15. Another 90, 30 feet. My register and boot, I've got another 5 feet for that. So I'm adding these up. I have 165 feet of supply air ugly duct. Go to the return side. That transition equated to a 20-foot equivalent. So on my return, I've got 20. My total ugly duct is 185 feet of duct. And that's not much. Look, 20, 35 feet with 3 elbows. That's a pretty standard ugly duct, is that right? I'm going to say that's, if I have an ugly duct around most homes around here, that's going to be really close to that. So with that, I'm going to take that 185 and I'm going to plug it in here. 165 plus my 20 equals 185. Everybody with me so far? All right. So with that, I can take the available static pressure times 100 divided by my total equivalent length. So do step 5 with the math, and we're going to say that ASP times 100 is 0.15 was my available, yes? 0.15 is my available, times 100 equals 15. Everybody follow that so far? Yes? All right, so that's 15. 15 divided by my total effective length, which we said was what?
185.
185. 15 divided by 185.
08.
0.08. So what is my supply static pressure going to be, or friction rate going to be? 0.08. Is everybody following what we did there? Okay, so let's take away the math. Okay, let's take away the math on it. Let's do it using the chart. All right, we know that we can go right here and use, what did we have? 0.15, yes? Plug 1.15 here. And then we said that we had on this side, on my total effective length was 185. I'll go right up here. So these two lines intersect here. You guys get this so far? If that goes there, I'm going to follow this line out. So where does the 0.08 come from? It comes from the ugly duct in the house. Should I do this on every job and figure out what I've got where and how? I'm going to say that example I use with the typical ugly duct is probably typical ugly duct in our market. That's why we ended up with that 0.08 for our supply. Is that helpful? Because somebody's going to challenge you at some point in time.
Yeah.
And when you do, you say, well, I got it from the friction rate worksheet, I took it off and got the, okay? So I just want you to be able to have that piece of information. Because there's going to be that job that you're going to get out on, it's going to be an uglier ugly duct. And you're going to have to change that again. Okay? All right? So, okay, look, let's make it ugly. Let's make it ugly. What was the ugliest filter we saw on there? It was like a 0.3 something?
3.36.
Okay, so watch this. We used 0.11 here. Let's put the filter 0.36. Get your calculator for me. 0.15.
Where is that? 0.15.
0.36 for our filter.
This is my report.
0.03 for our supply. 0.03 for our return. 0.03 for our balancing damper. What do we have for our device losses? Added those all up. What did you end up?
Adding them all together?
Yes, sir. Add these. 0.15, 0.36, 0.03, 0.03, and 0.03.
1.69? 0.6?
0.6. Look, we have 0.6 here. What do we have available?
0.5.
And you already put more resistance in here. I can't even size this ductwork because I've got more device losses than I have available on my ductwork, on my blower. Does that make sense? So my ugly duct got uglier. And in that case, 0.08 ain't gonna cut it. You follow?
Yeah.
Good. So what is our concentration when we start putting all this ductwork together? Make the ductwork large enough, make it straight enough, get the filter that I get enough air through it. A MER 16 is a great filter, but so is a brick.
Yeah.
I just can't get any air through it. Does that make sense?
Yep.
So we need to get the air through. So our concentration is to get the best airflow through the ductwork and the fittings. Fair? Okay, so that's where we got the 0.08. Now, you can say, where did the 0.05 come from? 0.05 from Manual D basically says, as long as you get as long as you get the supply side right, we want to slow the air down on the return side. So in order to slow the air down, I have to make the ductwork bigger. So this is a swag. This is Paduma. Swag is a scientific wild-ass guess, and Paduma is pulled directly from my area of expertise. Okay? So what we're doing here is we're just making the ductwork bigger on the return so we can slow the air down. Because in the supply plenum, we were running at about 7 to 900 feet per minute. Remember that? The return, they said, make it slower. So we have to make it bigger to make it slower. So we've dropped it down a couple of friction rate numbers, so we got the 0.05. That's where that comes into play. And what you'll see on this calculator when we start getting into it, you'll see that you can look at the CFM and you can see what the speed of that air is. And as long as we get it down in that rate that we're looking for, golden. And it works out to about that 0.05, okay? Sure. That's where we're getting that number, okay? So is it constant?
No.
No, it's not. It's a moving number.
Sure.
But is it a typical?
Yes.
Yes, that's what we're looking for, okay? Good. Because I know nobody's going to do this every time.
No.
Got it. But as long as you know how to do it, you can make changes.
And if we base our, Hunter, if we base our duct sizes off of these numbers, it gives us enough play where the numbers are slightly oversized. So Rude technically goes with this 0.1, okay, like that's what they want to see. Doing it at a 0.08 gives us the wiggle room to add this filter, to add these other things.
So where the 0.1 came from was back when we had coils that you could read a newspaper through. Right? So how much resistance is that? Very little resistance, is that right? So as the coils got more restrictive, the 0.3,
right.
When those got more restrictive, I had to make the ductwork larger because the blower was still only going to move X number of air. So that's where that 0.1 came from.
Came in effect where everybody's chasing efficiency.
Yes.
So, including the government.
Yes. All right, so let's move on past this. Okay, so everybody knows basically where that 0.08, 0.05 came from. Kind of nice to know where you guys are at now. It's neat to know where he's at in his position right now. Fair enough? Cool. All right. Better fittings, properly sized, ductwork, give the homeowner the more choices to install additional IEQ, because the more IEQ pieces I put in there, the more resistance I've got. So if I get the ductwork right, I can add some IEQ devices too. So let's look at the external static pressure on an electric air handler system. This is a standard air handler system. We're going to check it at the return. We're going to check it at the supply. And maybe I'm going to check it on the other side of the filter as well. Let's see what happens there. I have 0.8 total external static pressure. Let's see, that's 0.33 here, and it's 0.47 here. That's 0.8 total, is that correct? Yes? All right. Good. If that's 0.8 total, what if I measured right there and saw 0.4? What do I see between here and here? What do I see the difference is right there? 0.07. So 0.07, remember we were looking at those filters and I said 0.09 is probably a really good airflow filter. How's this one stack up right now? Because I'm measuring those two that you put in there, I'm putting them on both sides of this filter. So I know how much the blower's sucking on this side, and I know how much the blower's having to suck on this side. So that's telling me the difference. I'm knowing exactly what that filter is pulling right there. Does that make sense? 0.07. Is that a good filter for airflow? I got virtually no drop at all on there. Does that make sense? Good. But I see 0.7 and 0.33, 0.47, 0.33. What do I see about this whole total system?
Returns higher.
Returns higher, right? So the system's sucking, right? It sucks. If it sucks and it's not the filter, what must it be?
We return air.
Return air.
Size.
Size. Maybe the grill. Something's undersized there. Or maybe it's going up through a chase and half the chase is dinged off inside there. I've seen Jody send me some pictures the other day. We got this much space down here and it goes up and it turns and it has to go through a little hole this big. So the little hole is where the problem's at, right? Yes, sir.
You know what we see quite often, which I know you've seen these 100 times. You probably see them on service calls, where they think that just because they cut a hole this big in the wall, that it can still go through this stud cavity. That's only a 2x6. And then it gets to a can in the attic that stands up this tall, but it's still only this big. And they think that that's...
So really 2x6 is 14-inch centers, right?
Yeah.
So that means it's 16 inches, so it's 14 and a half inches between there. So I got 14 and a half by 5 and a half. So that's what we're going to size that for, is going to be 5 and a half by 14 and a half, not the 30-inch filter that they've got in there, because this is where it's plugged down on my hose, yes?
Yeah.
Okay, cool. All right, so we see that the problem's on this side, yes? Good, all right. So what is my total external static? 0.8. Okay, let's see what happens here. If I have that 0.8 total, and I have 0.33 here, and I have 0.47 here, and I have 0.21 here.
0.060? No, 26?
0.016.
So what's the difference between here and here?
Okay, come on guys, calculators, let's try to give them an answer.
I'm grabbing it.
0.26.
Good. So if it's 0.26, where does that stand on that scale of good free-flowing filters to restrictive filters?
Ooh, tight.
It's kind of on the restrictive side of the filter, is that right? Look, if I did this, if I just pull this filter out, it'd go, whew, but what would the static be on the return side if I pull this filter out?
0.47. 0.21.
There's the resistance. Pull that filter out, you've got 0.26 resistance on that filter. Now I've got 0.21. 0.21 here and 0.35, what's my total now?
0.54.
0.54, how's that working out on that scale? Feeling a little bit better. What is my return sucking anymore? Is it a sucker anymore? 0.21 versus 0.33?
Yeah.
Ah, so the problem with this one, where the other one was the duct work, not the filter, this one is the filter, not the duct work. Is that making sense? So now if I measure it here or here with no filter inside there, it's the same. You got it. You got it. Are you seeing how that tool can save your ass? Your butt. All right, let's look at it. 0.8 total. I've got 0.5 on the supply. I've got 0.3 on the return. I've got 0.23 on the other side of the filter. How's my filter doing?
0.07.
0.07. Not too shabby, huh? That's on the easy side, is that right? Mm-hmm. Good, so how am I doing total? 0.8, yes? Is that good or is that bad? That's when we have to go to the blower data sheets, right? That's where we're going to get into that installation instruction that you guys throw away all the time, right? We're going to break that puppy open. Yeah, we keep them. We keep them in the box that we throw in the truck. I got you.
Well, we just put them on top of the unit in the pack.
Look, as long as it's there, I still have the opportunity to go look. Is that right? Good. So what I'm going to tell you is every time you start up a unit, I need the blower external static written on there, so now everybody knows that this is what we started with. This system started off with this much resistance. Is that fair? Cool. All right, so we're going to roll it. You guys are not going to open it up. Mike's going to go up there and look at it, so he's going to break open the package because he's got superpowers. So he's going to go in here and he's going to look. The 0.8 total external static, he's gonna look at the model number, he's gonna
Go
go,
to 0.8 that doesn't exist.
oh, what? He's gonna go to high and go to 0.8, oh, look, it's over here, it doesn't even exist. What's going on now, guys? Is that blower gonna work? For a while. So what is going to happen? Okay, so look, let's see what, I'm going to run the scenario. The blower's going to run. Is it going to get hot? Is the motor going to heat up with all this resistance? Okay, the blower heats up and it gets really hot and it shuts down once that limit kicks, right? What's still running?
Compressor.
Okay, the compressor's running outside, blower's not running inside. Nobody knows any different because the homeowner doesn't have a clue, right? So this is not running, that's running. All of a sudden, we're pumping all this liquid up into the evaporator coil. And what's supposed to evaporate that back into a vapor? Air. Oh, the heat from the house. And if I don't have a blower moving that across, that liquid refrigerant goes all the way up. How much superheat do I have? None, because it doesn't superheat at all. I'm dumping that liquid right down that suction line, right back onto that scroll, and the compressor goes out. You go out there and you say the compressor is gone. What's running inside?
Blower.
It's back on again. It cooled down, it came back on again. What's not running outside is the blown compressor. You're pissed off because you just put this thing in 2 months ago. Where's the problem? You guys with me? We've got to be checking the external static. This doesn't get it. Cool? All right.
Or something else too. What if you've replaced the blower motor 3 times in the last 2 years or year and a half? And you go, why do these blower motors keep coming up?
Yeah, it's trashy blower motors.
Shit.
All right, so let's look at this. If I had 0.8, what am I going to end up with as far as for CFM? Smoke. That's what I got. I got smoke on that. So we're going to have to clean that up. Okay, so let's look at, here's an upflow. Gas heater. Do I have to go between the gas heater and the coil?
Yeah.
Why?
Because they're separate.
Because they're separate. I want to go total external to the cabinet that has the blower in it. Yes? So here and there. I need to figure out what that static is on there as well. So in this case, I have 0.93. How's that looking? It might be a little bit on the high side. We're thinking might be, all right? So let's figure out what happens. I've got 0.73 on the supply, and I've got 0.20 on the return. Help me out. Where do you see any issues? I've got a lot of static where? On which side of the system? It's all on the supply, is that right? It might be more supply ducts, is that right? Could very well be. Could be that the grills are all closed, is that right? We don't ever have customers that close grills. Okay.
They balance in it with the hand on there.
Yeah. So let's look at this. Let's see. Okay, let's take another one on the other side of the coil. So we're on this side of the coil and on this side of the coil. I've got 0.23 up here. So what's the difference between these two readings?
Way too close.
0.5? Remember those readings on those coils? Even the highest restricted one that I showed you on there was like a 0.3, wasn't it? Right now you got 0.5 on this coil. What do you think's going on with this coil?
Coil's dirty.
Coil's dirty. Yeah, coil's dirty. But I couldn't get it out because I couldn't see because I didn't take the panel on because they had it all pookied in and everything else, right? But real quick and easy, I was able to identify where my problem was on this system. And if I did get this down to about a 0.2 across here, that 0.23 plus my 0.2 would be a 0.43 now. Does that make sense? So yeah, we probably could straighten this whole problem out by just cleaning the coil. Do you see how this tool can help you out? Okay, good. So ductwork, we'll be using a typical TEL of that 185, that ugly duct, that's what we're going to use. That gives you a friction rate of 0.05, 0.08 on your supply and your return. The 0.05 is used because Manual D recommends that the supply friction rate be used and then adjusted as needed to the larger size to meet the recommended velocity. I covered that. All right. You walk into the job. You walk in, you measure it out, you see that you got a 3-ton system. You got 6 8-inch metal branch ducts on there. You have 2 14-inch metal return ducts on there. You have 2 12 by 20 filter grills. You have a 14 by 12 metal supply trunk, and it's all wrapped insulation on all of that. Everybody okay with that? Good information. Everybody's got it, yes? Good. Take your duct calculator, and we're going to find what an 8-inch metal duct will take care of. The 3-ton system is going to give me about 1,200 CFM. Is that what we're going to need to get? Yes? All right. So what I'm going to tell you is that 8-inch duct is going to move about 210 CFM. So let's look at it. It's a metal duct, is that right? It's a round duct. What size duct did we say it was?
8-inch.
8-inch. So go to 8-inch round. 8-inch round. When you go to 8-inch round, we're going to go to the galvanized metal duct because it's wrapped on the outside. Is that right?
Yep.
Galvanized metal duct. We said that we're going to look at the supply air at 0.08. So galvanized, go up to 0.08.
Should be around 200.
And does everybody see around 210, something very close to that?
2 10-inch.
Good. Everybody all right with that? Good. So an 8-inch round is going to get you about 210 CFM, as long as it's metal. Is everybody good with that? All right. So, good. So I said it was going to be about 210. If I have 6 of those, 6 times 210 is
1260.
1260. Is that going to move my 1200 CFM that I need to move?
Yes.
Yes, no?
Yes.
Yes, okay, good. I thought I heard a no somewhere, all right. I had 2 14-inch metal returns. So, I'm saying it's going to move about 700 CFM each. Let's look at that. We're going to find that metal return, and it's going to be what size, what friction rate?
0.05.
0.05, all right. So we're going to line this up on 14. Everybody good?
Yep.
Okay, 0.05.
7 point.
About 680, 690.
Yeah.
You can call it 700.
Let's call it 700. Fair enough. Look, depending on where they put that rivet right there in the middle down here, depending on where they put that rivet is going to change it just as.
Is Burton near?
Yeah, it's Burton near. All right, we good with that? So let's call it 700. Are you guys good with that?
700 times 2.
So, but look at this. What's the speed of that air? Look, see that 700? We have 700 CFM, and what's going to be the speed of that air going through that return duct?
680-ish.
Yeah, how's that doing for our, remember our velocities that we were talking about on the back? Good. We went 6 to 7. How are we doing?
Perfect.
Good. So that's, my world is good. Good. But I had to get it down to 0.05, because if I was up at 0.08, that velocity would have been a lot higher. Okay? Cool, all right. So that's why we went to that 0.05, good. All right, so we have those 700 each, 1400. We have 2 12 by 20 filter grills. Remember what we said. If I use a 12 by 20 and I say height times width times 2, it will give me the CFM that I can run through there. Is that right? So let's do 12 by 20, height times width times 2.
480.
Good. And we have 2 of them, is that right? Good. So the total I can get through those grills is,
960.
and this is a,
1200 3 ton.
yeah. Do I have a problem? Yeah, return grills are too small, is that right? Good. Let's look at the supply trunk. I have a 14 by 12 supply trunk. It's wrapped on the outside. So I'm going to say it's about 900 CFM. Let's look at it. 14 by 12. Now, if you look at this, you're going to see 12, then you're going to see a number that slides all the way over here, and then it comes up to the 14. Or you can go to 14, 12 by 14 here. So either 14 by 12 or 12 by 14. Either way, whichever one is easier for you to line up, line that one up. In this particular case, it looks like it's easier for me to line up the 14 white with the 12 gray. 14, 12. Does everybody see that? Yes? Okay, 14, 12. All right. So, that plenum is 14 by 12 wrapped on the outside, so that'll be galvanized. Is that right? Good. So I'm going to go to the galvanized metal here. Is that a supply plenum? Yes. Supply. So I'm going to go to what? 0.08, right? 14, 12, and 0.08. How much air can I move through there?
100.
Good. So I was right. It was 900, yes? So we got problems with the return air grills and the supply air trunk. That's where your biggest problem was on that one we made the loop on, okay? Supply air trunk. So good, we're there. So does everybody see how we did that? Okay, so that's what we got. System's undersized supply trunk and undersized return grills. We're going to fix that, is that right? Sure. But a lot of the insulation was all torn off. You saw a lot of leaks in the ductwork. So you say, we're going to do what? We're going to replace the duct system, yes? Mm-hmm. Good. So what we decided to go back with is we're going to go ahead and put in the 3-ton system, still has the 1200 CFM. We're going to put in 6 8-inch flexible ducts. We're going to put in 2 14-inch flexible ducts, and we're going to tie those tight and make them nice and neat. We're going to increase the filter grills to 12 by 25 grills, and we're going to increase the supply metal trunk to 18 by 12. So let's see what happens here. The 3-ton system has 1200, yes? Good. Go to the 8-inch round on your duct calculator. Now we're going to go to flexible. Go to 8-inch round on the flexible, go to 0.08, which is a supply grill, a supply duct, yes? And how much air do you see you're going to move through there?
150.
Do you see the flexible duct?
Yep.
0.08.
150 CFM.
Oh, yeah.
Okay, so you got him here.
Yeah, I got it now.
Are you good? 150? No, definitely maybe or not? You got it. Okay. All right, so you got it. Got 150 times 6 ducts. How much air am I moving?
900.
Oh. How much am I supposed to move?
1200.
What just happened?
Oh shit.
Probably should have made those some 9s.
We made those 8-inch metal and turned that into an 8-inch flex, and I can't move the same amount of air. I typically would go one size
Bigger.
larger. Okay, so we know we screwed up already here, right?
So now you have a 2-ton unit.
Yeah. So let's do that 14-inch. Go 14-inch round, and again, this is flexible. 14-inch round, flexible duct. It's a return, so it's going to be 0.05. Good. What am I moving there?
510. 525. I think mine's off to the.
Yeah, okay, so 510, 525, 5 anything. Are we short? We were good with the metal, but as soon as I went to the flex, that side went stupid, didn't it? Good. But we did increase the filter grills. So 12 times 25 times 2, right? We increased that size, 12 by 25 times 2. And I have 2 of them.
1200.
Yeah, 600 times 2 is 1200. Very good. So is my return air grill size right now? Yeah, that's good. Let's take 18 by 12 on that rectangular duct. And again, this is metal duct, it's wrapped on the outside. We went to 18 by 12, so go to 18 times by 12 on that calculator on the side, on the rectangular. 18 times 12, and it's a supply, so it's going to be 0.08.
About 1250.
Yeah, I thought it was somewhere around there, 12. Huh? Good. So you with me on that? You good? You definitely maybe, or you got it?
Yeah.
Don't stop me now if you don't have it. I got two guys standing there like a couple of vultures waiting to pounce on y'all so that they can help y'all out right there. So I need to make damn sure you guys got this. Yes, we're good?
Got it.
All right, so did we do my customer a proper job? No, I didn't. I got the part that was wrong right, but I had the part that was right wrong. So now we got to do something else. What should we have done?
9-inch ducts.
9-inch on my,
Perfect setup.
oh, what else do I have?
Underside turn, David.
The flex up the
Flex.
You got to upsize all the flex.
Yes, so now I have to go up from a 14 to a 15?
16.
Jumping up to a 16, is that right? Good, so let's just check that. We're going to go 6 9-inch ducts, yes? So find the 9-inch. 9-inch round, go to flexible duct, 0.08 because it's a supply. Okay, good, so now we're hitting 200, and with 6 ducts, how did that work out for you? Yeah, talking dirty now. All right, so let's go to that 16-inch round, 0.05.
720.
What? I got about 700 or 1,400 total, is that right? Good, you guys good with that? All right, and we already checked those, we know that that was right. And we checked that supply trunk, we knew that was right. Now did you do your customer a proper job? Absolutely you did. Absolutely you did. But we had to size it right. Otherwise the static's going to be through the roof. Static's through the roof, what happens to CFM? Down through the basement. That's it, that's it, that's it. Here's your turn. This is what I told you, Brady. This is where you can do this every day of the week.
Okay.
Okay? You've got a 12 by 25 supply air metal duct, but it's lined on the inside. So duct with liner, where am I going to look at that? Very bottom, down at the bottom. Look at it down there with duct with liner. I got a 12 by 25. I'm giving you the free area inside that duct. 12 by 25 supply air metal duct. It's lined on the inside. Supply is going to be 0.08. Absolutely. 12 by 25 lined metal down at the bottom.
1,500 C.
What? Did you find 1,500?
Yep.
Did you find 1,500?
How'd you find it there?
The 12 to the 25. Make up.
I got 12 by 25.
You go to your 12.
There you go.
Where you went? Wrong.
Why?
12 by 25.
Because you have to go to this part of the chart. Rectangular duct. Okay. 12, right here. Match it up with that 25 number that's right there. So you got 12 by 25 duct.
Yes, it is.
0.08, 1,500.
Got it? Sweet.
Okay.
Sweet. Sweet. That's good. Okay, so we got duct with liner. You know where to go for that, yes? All right. Now we've got 15 by 25 return air. It's metal duct, but it's wrapped on the outside. Where am I going to look at this one?
At the top.
Galvanized at the top. Very good. Good, good, good. Find it. 1525. Return air. Return air is 0.05. Good. Now let's figure this one out.
1,400.
Okay. Yeah.
1,400. Oh, 1820. 12 by 25.
15 by 25.
Oh, 15 by 25.
Yeah, that's that big 1.5 right here.
Yeah. That's where I extra.
You're looking with David's eyes over there.
25.
David, I told you that was a 5 and not a 2.
Yeah.
1950, got it.
We're good? All right, sweet, guys, look. All right, let's do a 18 by 20 return duct board. This, Brady, this is the thing. This is what you're gonna be doing on a daily basis until these guys get this. Just fill in any damn number you want, but make sure they get it right. Cool?
Don't get
Yeah,
this
yeah.
wrong.
You good with, you with?
Duct board.
Where's duct board?
Bottom right.
Good.
Okay, so
It's a return, so it's 0.0.
0.05 right there. Okay.
Duct board doesn't give you 0.05, you gotta kind of look at it, is that right? Yeah, you gotta be between the 0.6, and, yeah, and see, that's especially why I put that in there, was just because of that. Duct board doesn't give you 0.05, you have to look between the two numbers.
lines in between.
Yeah,
I got you.
okay, is everybody good with
It
that?
just depends on, this part here, sometimes you can use, you can use this number and this number, but sometimes you want to take that 25 and put it here, and then put the smaller one here. You have to see which one's easier to be more accurate.
Gotcha.
Good?
Yes, sir.
All right. 12 by 12 return air metal duct with liner. 12 by 12.
That should be good.
Return air metal duct with liner. 1212.
I'm getting about 475, 480.
So that's 0.0600.
Here's what I want you to do right here while they're looking that up.
450.
Go to 1820 return air duct board. Look at that return air duct board.
Okay.
Line that up.
Yeah, 480.
And then hold it with your thumb so it doesn't move.
18 by 20. You said 18 by 20.
1820 return air duct board.
Okay.
Good? All right, so how much air am I gonna move through there?
1750-ish.
Okay, about 1800, right? Okay, you with me so far?
Yeah.
All right, so holding that right there, and we're gonna do lined metal duct, right?
Okay.
So tell me how much air I'm gonna get through a lined metal duct with that same free area inside on that return.
1500.
Good. So what you're telling me right now is I can move more through a duct board return air than I can through that lined metal duct.
That much difference in the friction?
Yes, it is.
But it is
Because
because for one thing, it's lined.
it's lined, it's glass,
Surface area.
it's glass all the way through. So this is what's
I'm
happening.
saying free area.
Yeah, oh yeah, your free area is the same. But the friction rate on that glass line versus that running down that lined metal duct on the inside. Isn't that crazy? So when people start saying, oh, I hate duct board, I hate duct board,
All those would have been pretty close.
I thought it would have been a lot closer. But every time I do this
Much more
class,
friction than an unlined duct, but I would have those two would have been pretty close.
but I wanted to make sure that everybody understood, hey, flex duct, metal duct, things.
The language emails would be proud to see that.
I got 23 minutes left.
I got about 5 minutes here.
Good. I didn't know if I need to start looking for some more memory.
I think we're good. All right? Everybody good so far?
sir.
Okay, we're gonna change it up just a little bit. What size return air flexible duct should I run to be able to move 2 tons of air? Oh. How much air do I need to move on a flex duct? On a 2 ton? 800. So what you're going to do, go to flex duct at the top. This is a, what size return air? This is a return air, so line up 200 with 0.05.
And then look at your round up and see what it confused to.
You got 800 CFM through that 0.05, so line up 800 to 0.05.
100 with the 0.05.
So what size duct?
10.
0.05, I'm sorry, 800, not, I screwed up earlier, 800
Well, I have a bit
CFM,
between
2 tons.
14 and 16.
Yeah,
800.
I'm gonna go with a 16.
because I can't damper
Point
up, right, I can only damper down.
Yeah.
Good.
I had it on 200.
I'm gonna tell you it's 18.
What you need.
So look at it and see, I think you'll see that it's 18. I think it falls out at about 17 if I'm not mistaken. So 800 at 0.05 on the flexible, on flexible.
And 800.
Right, yeah.
It's gonna go up to,
No, you're at 0.08, 05.
Oh, I'm with the wrong one, man.
And if I'm not mistaken,
That's
it's
what
on
I'm
the
saying.
it's
No.
got
Got it.
18-inch return flex is
18.
Still, well,
975.
So it'll be 18.
this is messed up.
I'll get you there. But I needed, the 17 didn't give me 800. I mean, the 16 didn't give me 800, so I had to jump up to the 18. But what will it give me? And I'll get you that in just a second.
Because it just so happened, I looked at it yesterday with a customer.
Good.
He decided something.
So the 18 is going to be able to take care of the 800 CFM, right? And we saw that it was a little big too, is that right? Good, because we really needed, what, 17? Good. So with that,
17 there,
Yeah.
but we're gonna use 8. That's why.
so with that, we're going to look at, this is a chart that's available. Where do you think this chart's available? Yeah, it's on the app. It's there. So,
What?
It's on my phone.
It's what?
sir, it's free! So look, here's all your metal duct. Yes? Metal duct, flex duct. Everybody good? Supply, return. Supply, return. Remember we said that we had that 8-inch. Oh, well, let's go back here. 18 inch is going to move 975. Will that take care of the 800 that we're trying to move?
Yes.
Good. All right. So remember we had that 8-inch metal, and we said we had 210 on that. Is that right? But when I got to the flex, I need the 9-inch to get that same 200. Is that right? Good. So again, stepping one size larger to be able to get the same amount of air that I need.
Now look at this. How many 5 tons if you went to with 120 inch or let's say 120 inch going into the back of the furnace? Are we moving enough air?
We lost 15.
What do you think the static pressure is going to be when you have this?
Oh.
Does that make sense?
Oh, yeah, but you gotta put, the proper way to do that, if you want to get the right amount of air through a 5-ton and a 20-inch flex, is you have to put a flat metal plate.
And cut it.
You have to cut it around 20-inch around the hole.
Yeah, you got to cut it
Put a
oval.
box.
Got to put an egg on there.
And you gotta do the same thing on the other side.
No, just tell them to shut up, all right? Because all right, so I have this available, is that right?
Yep.
Good, this is a good chart for you too. You got this on your phone app as well. What else do you think I could do for you to be able to make it any easier? What if I said the 8-inch supply will come up as this? So you just keep dropping down the menu to whatever size you want, whether it's flex duct or metal duct, and I built it that way for you too. So all of it's available to you. Free.
It's free?
Free. Guys, listen, I'm not doing that. Yes, I am. Okay, I'm going to do this. Here's what I'm going to do real quick. I've got a 4-ton system. I need a 24 by something return air grill. What do I need to have in order to be able to get 4 tons of air through a 24 by something return air grill? Height times width times 2, is that right? So pick a number.
30.
24 by 30, do it. 24 by 30 times 2.
1440.
Is that enough for 4 tons of air?
Oh, shouldn't I went at 2436?
2436, try it.
Yeah. Did I do it?
Yeah, 1728.
Good, so you seeing what we're doing there? We're taking a CFM that we have to move, and I have to build a return for that. We're making it happen. Everybody good? All right, conclusion, guys. Air conditioning is not just blowing air. It's the process by which comfort conditions are maintained within a structure, including but not limited to humidity control, particulate level, temperature level, ventilation, airspeed, air volume, and noise levels. That's air conditioning. That's what we're doing. We're not in the heating and cooling business anymore. We've gone well beyond that. So start acting like a professional when we're out there on the job site. quit using your handometer like a rookie and start getting into the tools that we were told to use. I gave you a toolbox full of tools here tonight. You guys have a ton of tools that you can use, and how much did it cost you?
That was all free?
It's free. Free. Use them. The tool that doesn't get used turns to rust, and that becomes a wasted tool you'll never be able to use. Use these tools. Go to your house, start using these tools and measure it out. Is that fair? Good, guys. I can't even thank you enough for allowing me to be over here. I hope you learned something. I hope you'll take it and use it. I got into this industry almost 45 years ago and did not know anything. So I'm taking all of this valuable knowledge that I've picked up over the years and building you guys a bridge that you don't have to walk through the same sludge that I walked through. You guys got a beautiful bridge to walk across. You got a choice to either get down in the muck and mire and play that game or elevate your game and walk over the bridge. I want you guys to elevate your game. Fair? Cool. Good luck to you.